Hello everyone, and welcome back to another GIS Mathematics lecture video. And in this lecture video, I want to talk about converting from Cartesian chords to polar chords. Right, from Cartesian to polar. Okay, so basically, to reiterate what I'm getting at here, is to go from xy to r theta. Okay, how do we go about doing that? And I think it's going to be easiest to do that through an example. So this example, right, we have the point 3, 2. Okay, and I think it's easiest to think about this using the trigonometry of right triangles that we've talked about so far. And so what I'm going to do is I'm going to draw a triangle that has this right here as one of the vertices, the origin as one of the vertices, and then if we were to draw a line straight down parallel to the y-axis to make a point there. Okay? And I'm going to draw in the sides of the triangle. So if we have a triangle that looks something like this, right? What we can do here is we have this angle here, right? This angle right here, this is theta, right? And this distance right here, right? This is r. So maybe this might be the best way to talk about the relationship, right? Is that what we've done is we've taken a Cartesian coordinate, right? And we're describing it now in terms of theta and r. Okay, so let's go ahead and let's talk about theta first. Let's talk about theta first. Well, what is theta? Well, let's see, what do we have here? Well, we know a couple things. We happen to know that the length of this line right here, right, we happen to know that this is going to be the same as the x coordinate. Right, this length here is x. So in this case, that's going to be 3, right? We also know that this length right here, right, this is the same as the y chord, which is going to be 2 in this case, right? So we know the length of the opposite side, and we know the length of the adjacent side of our angle theta here, okay? So we know enough information, just given what we already have with this point, to be able to calculate the tangent, right? Because we know that the tangent, right, the tangent of theta, we know, right, SOHCAHTOA is op over adjacent. And so we know here, right, that our opposite is our y, which I'm going to use blue here, over our x, right? We know this, right? We just described this triangle here. And so we know that our tangent is equal to y over x. So if you remember back to our previous video talking about arctangent or inverse tangent, right? If we feed in the tangent value into the inverse tangent, it will give us back our theta, right? So our theta, right, our theta here is always going to be equal to the arctangent, right, of y over x every single time, okay? So let's look at our example here specifically, right? So in this specific example, right, theta is going to be equal to tan -1, right? And again, these two things are equivalent. Tan -1 and arctan are the same thing. Of the y coordinate, which in this case is going to be 2, over the x coordinate, which in this case is going to be 3, right? And that's the 3, 2 coming from our Cartesian coordinate. Okay, so let's go ahead, bring up our calculator. Let's delete what we were doing from the previous video here. And let's go ahead and do 2 divided by 3. Make sure we're in degree mode because I like to work in degrees. All right, so again, to keep the arctangent, we do Shift and T. And you'll see that this is tan -1 of our tangent here. It is roughly 33.7 degrees. So we know that our theta now is going to be roughly 33.7 degrees. So that's our theta. So now what is our r? What is this distance right here? Well, we already know this, right? If we think back to our properties of right triangles, we know the Pythagorean theorem. So I'm going to give myself just a little bit more room here. All right, so we know that r, right? We know that r is going to be equal to the square root, right, of x squared plus y squared. Right, that's just a fact in this case. All right, so then let's go ahead and look at it for our specific example here. We know that r is going to be equal to the square root of 3 squared, which is our x, plus 2 squared, which is our y, which is going to be equal to the same thing as r equals the square root of 9 and 4. Okay, because that's 3 squared is 9, 2 squared is 4. So r is going to be equal to the square root of 13. Now, obviously, this would be the end of it right here, right? Because we can't reduce that anymore. But let's just assume that we wanted to figure out the exact value, right? We could pop back into our calculator, type in 13, and we can hit the square root button. And we know that that's approximately equal to 3.6. Right, this is going to be approximately equal to 3.6. Okay. So, circling back up to our original problem here, right, our r and our theta, let's do this in purple. Right, our r and our theta is going to be 3.6, comma, 33.7. Okay, so this is our final answer. Hopefully that makes sense. Again, basically, you're going to be keeping track of the fact that theta is going to be the arctangent of x of y over x, and your r is going to be the square root of x squared plus y squared. So hopefully that makes sense. Hopefully this conceptual diagram here makes sense. And if you have any questions, please reach out. Thank you.